Hello friends, welcome to my channel. Let's have a look at a newly appeared easy problem. Problem 2600. Key items with the maximum sum. In this problem, we're going to introduce the piecewise constant function, right? So first, let's look at the problem statement. There is a bag that consists of items. So these items can be +1, 0, or -1. So we are given four non-negative integers, num1s, num0s, and num-1s, and the key. So we want to pick exactly key items among the available items. We would like to return the maximum possible sum of numbers written on the items. So before we look at the examples, let's look at the constraints. So first, the numbers involved is bounded above by 50. In other words, this problem size is not very large. And the second constraint or assumption is an important one. So here key is greater than or equal to 0 and less than or equal to the sum of num1s, num0s, and num-1s. In other words, the k is less than the total number of items in the bag. So in example 1, so we have num1s 3, num0s 2, and non-negatives are zeros. So k equals 2, right? So in this case, we'd better to pick ones as long as it's possible, right? So we pick two ones, so we get 2. And in example 2, everything remains the same, but k equals 4. So in this case, we can pick the first 3 ones to get a sum 3, and then we pick a 0. So we can pick 1 zeros, right? So I would say that the two examples are not very representative, because we can have positive number of num1s, and if we have a relatively small case, so we have to choose some part of negative ones. In that case, so we need to consider the total sum, total number of non-positive ones minus part of the negative ones. So with that said, we are ready to do the coding. So for this, actually this is the standard if-else block. So first, I'm going to discuss the relative value of key with respect to the num1s, num0s, and non-negative ones. So the strategy is very obvious. We want to choose number 1s first, and then number 0s, and then non-negative ones if we need it. So first, if k is relatively small, for example, is less than or equal to num1s. So in this case, we can choose the key items from the bag with number 1 on it. So we are going to return key. This is one case. Otherwise, if k is larger than the number 1s, but it's smaller than num1s plus num0s, so in this case, we choose all these num1s items, but then we need to choose some zeros. But that part does not contribute to the final sum, so we just return num1s. So this case corresponds to k greater than num1s but less than or equal to num1s plus num0s. So in this case, we're going to return num1s. So otherwise, so we know that we need to choose before we choose this num1s plus num0 items, we need to remaining ones, we need to choose negative ones. So in this case, for the choice of num1s plus num0s, so the sum is num1s, and then we choose some negative ones. The item we choose is actually k minus num1s, then minus num0s, right? So the contribution of each item here is a negative 1, right? We sum the num1s and then we sum the negative 1. Then this is our score or sum. So with that said, I guess this several lines forms a solution format to this problem. So we can first do a test. Yeah, it passes one example. So now let's change this, right, to be say 4 of right. Let's say 4. So this still give us 3, right? And then if we have some values, let's say 15 negative ones, then we choose 3 plus 2. Let's choose 10, right? We need to choose 3 ones, and then this is the 5. We need to choose 5 negative ones. We're going to get negative 2, I guess. Yep. So let's look at the generic case. Yeah, it passes all the cases. So now this format basically is a if-else block in the perspective of coding or in computer science. And in mathematics, actually, this gives us a typical piecewise constant function. So let me copy this part and then write in terms of a piecewise constant function. So this is, let me mark this one as if else if else block. So in other words, this is control flow. And then I'm going to mark this as V1. And then I'm going to actually change or modify this a little bit. So first, if k is in this range, so we're going to return this number. So that's constant. So what we are going to return is k times integer. So we want to check if k is less than or equal to num1s. This is one case. And then in this case, so this k, we are going to return num1s. So num1s. So for this domain or this interval, so this corresponds to whether k is greater than num1s and less than or equal to num1s plus num0s. Then we're going to do so let's see this number. So we're going to return this number, right? Let's put a parenthesis here. So this corresponds to the interval k is greater than num1s plus num0s, right? So this way, so we have a piecewise constant. The 3 constants are k and num1s and this number, right? So basically, you can check this. You can simplify a little bit. Num1s, this num1s cancelled. So we're going to have k minus num0s. So let's also test this one. Let's see. What's the problem here? So k is strictly large num1s, num0s. K int k less than and k. Oh yeah, let's see. Let's see, num1s plus k times this one. We check if k is int k is larger than this num1s plus num0s, and then k. Let me change this one. Let's check again. 3 to 15, 10. Let's see what's the problem. So here k times int plus nums times int. K is less than or equal to, then plus num1s. Oh, here. So I guess should be minus. So you can simplify again. So this is num1s, 2 nums1s minus k plus num0s, right? Let's check. Oh yeah, let's pay attention to the symbols. So because here we cannot directly copy this one because we are multiplying negative one. So now let's look at the generic case. Yeah, it passes all the generic cases. So let me make some annotation to finish this problem. So here is a piecewise constant function. So with that done, so basically in the first version, we just use a verbose solution. Basically, we have discuss different cases, and in the second one, so we wrote in a piecewise constant function. So this function can also be simplified. If you like, you can have a try. So with that said, I guess that's about it for this simple problem. So yeah, that's about it. Thank you.